Welcome, my geometry friends, my geometry students, families of students, whoever may be watching. This is going to be our geometry notes for 6.2. Today we're going to be talking about proportions. Most of you have probably already seen proportions before, so this will most likely be a review. And then we'll add in a couple little geometry elements to this. The first thing that's important when talking to proportions is actually starting with this, starting by talking about a ratio. A ratio is simply put, we're going to be comparing two quantities, two things. We're comparing, seeing how they're similar. For example, a recipe takes 1 cup flour and 2 cups sugar. I'm not a baker, so I don't know how realistic this is. I don't know if you need more flour or more sugar, but we're just going to go with it. When we write a ratio, typically, we write ratios in two different ways. The first way is that you could say, oh, we're comparing flour, and then we use a colon. A colon is, of course, the two dots above each other. We're comparing flour and sugar. So if we took this recipe, we would write this ratio as 1 to 2. The other way to write a ratio is as a fraction. So if we wrote it as a fraction, we could write flour as our numerator, sugar as our denominator. What that means is our ratio would look like 1 over 2. 1 cup of flour, 2 cups of sugar. In this class, we will want to use fractions. So if you're familiar with that colon method, great. However, for the purpose of this class, we'll want to use a fraction. So if I took this recipe, 1 cup flour, 2 cups sugar, and I asked you to triple it, what would you do? What to do if you triple the recipe? Oh, sorry, my nose is itchy today. Well, if we started with that ratio of 1 over 2, 1 cup of flour over 2 cups of sugar, if we triple it, well, if we start with 1 cup of flour and we triple that, we're going to end up with 3 cups of flour. If we triple 2 cups of sugar, we're going to end up with 6 cups of sugar. So we'll end up with 3 over 6 as our ratio. Times 3 may be all right. What we just did is we just set up a proportion. So here, ratio, haha, beautiful. A proportion is this. Proportion. A proportion is just two ratios that are set equal to each other. So another example, maybe we could see 4 over 10 would equal 12 over 30. Two ratios that match. See, if I reduce this 12 over 30, it would reduce back down to 4/10. So the thing is that those ratios have to be equal to each other. So maybe if you can think of where I'm going with this, in our class, is this the same color? Yep. In our class, we're going to solve for the missing variable in a proportion. What that looks like is we might see this. 2 over x equals 4 over 26. Here to solve, we do what I'm finding has many names. I've heard it called the butterfly method. I've heard it called the fish method. I've heard it called, and what I will refer to it as cross multiply. This is where we multiply the corners together. So here we circle or highlight the two corners and we multiply them together. So I get 2 times 26 equals 4 times x. And that we'll just take and simplify it to find x. So 2 times 26 is 52 equals 4x. Then we divide by 4, giving us our answer of 13 equals x. So we will see proportions where we need to solve for a piece of it, or solve for a variable. Let me show you another example of a proportion problem we will be working with that elevates the difficulty. We will see something like this. K plus 6 over k equals 4 over 7. This is still a proportion. We still have a ratio equals a ratio, or a fraction on both sides of that equal sign. The thing is, when we look at cross multiplying, there's something that we want to be extremely careful of. So I'll go ahead and highlight my corners. What we do, see this k plus 6. What I want you to do is when we see something like that, we want to put parentheses around it. If there's two things, if there's like a k and plus or minus something, put the parentheses. Because what that's going to end up looking like is this. It's going to end up looking like a distribution problem. We have to take this 7 and multiply it to both the k and that plus 6. So that's why when we write our next step, we write it as this. When we multiply that out, we'll get 7k plus 42 equals 4k. Well, now to continue solving, we want to see all of our numbers on one side, all of our k's on the other side. Right now I'm seeing we have k's on both sides, so let's just group them together. A nice SPO. Then we can finish this up by dividing both sides by -3. And when you do that, we get -14 equals k. There you go. This is a big piece. Remembering to put those parentheses and then distribute that multiplication is a big piece. You get an opportunity to practice some of that on the practice. The other element that we're going to be bringing in with this is word problems. So our favorite, we love to see word problems in math. I know all of you watching are shouting for joy, saying, yes, finally, we get some word problems. Here we go. A flagpole casts an 8-foot shadow. If you are 6 feet tall and cast a 2-foot shadow, how tall is the flagpole? When we read something like this, our goal is going to be to put this into a proportion. Let me go ahead and highlight some important information. I see we're talking about an 8-foot shadow here. I see we're 6 feet tall and cast a 2-foot shadow. And the question being, how tall is the flagpole? So I'm finding my numbers and the labels that go with those numbers. 8-foot shadow, 6 feet tall, so on and so forth. This is going to help me create my proportion. What we want to do is create just off to the side our labels just to help us keep track. What two things are we comparing in this problem? Well, we're comparing the length of a shadow and the height of the height. So we'll go ahead and write that. We're comparing height of an object and the shadow length. Let me move this over so we can see this as kind of an indentation. Well, go ahead and write that off to the side just to keep track in your brain of how we're going to set up this proportion. When we start, well, where do we see a height value? A flagpole casts an 8-foot shadow. That's not a height. Okay, here. If you are 6 feet tall, well, that's a height. So let's go ahead and put 6 feet tall, and you cast a 2-foot shadow. Okay, so this tells us 6 feet tall and a 2-foot shadow. We're going to have that equal something else. Well, let's go back to that 8-foot shadow. If we know that flagpole has an 8-foot shadow, well, notice the question, how tall is the flagpole? We're trying to find how tall the flagpole is, right? We're trying to find the height of this flagpole. Well, if we don't know something, we can put a variable in that spot. So let's just put x. Do you see now how we've created our own proportion that we can now solve? We can now do this math, which would end up being, let's see, 6 times 8 is 48 equals 2x. Remember to multiply those together, giving us that 24 equals x. So on your practice, you're going to see a ton of these word problems because I want you to get really comfortable with that. Let's maybe do one more word problem, and then we will be done. So let me think. The shadow problems are really popular, so let's do another one of those. If I am six feet tall and cast a 1 foot shadow, how long is the school's shadow if the school is, oh shoot, what is it? My estimation skills are not very good. We'll just say 120 feet tall. Sure. So we have a couple steps. The first step, I'm going to make note of the important information. I see 6 feet tall. I see a 1 foot shadow. Oh, there's the lunch bell. And then I see we have a 120 foot tall building with the question being, how long is the school's shadow? So when we look at that data, we can see once again, we're looking at comparing the height of something and the shadow length of something. Well, when I read this, I can see that I am 6 feet tall, so that goes to a height, with a 1 foot shadow. Cool. When I look at the building, we see that the building is 120 feet tall, and we don't know the shadow length right now. So that's where we put our x. Once again, do you see how we've made a proportion here? Now we can go ahead and solve that. So I can say 6 times x equals, I'll go ahead and write this out, 120 times 1. Well, that just becomes 6x equals 120. When you divide both those by 6, we get our answer of x equals 20. There you go. That's what we're doing today in 6.2. Just looking at proportions, getting really comfortable with those. Thank you for watching. If you have questions, feel free to let me know, email me, or ask me in class. Have a good day.